Hey guys, I probably should have told you in the last video that you might want to follow along in your book as we do these lessons together because that's where I'm getting my info from. We are on lesson 1.2 and I will write that down up here at the top. Lesson 1.2 so you'll know where we are. We're going to talk about the commutative properties for addition and multiplication first today. When you think about a commutative, it comes from the word commute. And let's say when I commute to work in the morning, I'm going from one place to another. I'm moving my body. So commutative properties in addition and multiplication are simply moving the variables around. So even before we think about before we think about algebra, if we just look at the numbers 3 plus 4, we know that equals 7. We also know that we can say 4 plus 3 equals 7. It doesn't change it at all. We just commuted. We moved them around. We moved the numbers around. So because multiplication is the same thing as addition, just faster way to do it, we also know that when we multiply, we can move those numbers around. So if I said 8 times 2, we know that equals 16. I can also say that 2 times 8 equals 16. It doesn't change the value of it at all. So when we come to algebra and we start to see the fancy way of writing numbers and variables, that means those letters that could stand for different numbers that we put in them, the same thing applies. Okay, so if I said you have A and B, look at that. I meant to write a D for and I wrote a B. Sorry about that. That's why I shouldn't write what I'm not saying. A and B. Alright, I can say A plus B equals B plus A. All that is taking what I just told you about 3 plus 4 and 4 plus 3 and turning it into an algebraic expression. So that's addition. And we can do the same thing for multiplication. If I have A times B, it equals the same thing as B times A. Alright, so that is the commutative property. You're commuting, you're moving from one place to another, just switching it around. The commutative property for addition and multiplication. So let's change our color. Hopefully the brush size will stay the same for me. And we can do an example. If I told you to take y plus 5, alright, take that algebraic expression and write an expression equivalent to that using the commutative property, all you have to do is switch that around. Y plus 5 is the same as 5 plus y. Okay? Now we can do another. I should have labeled that example. I told you guys I was going to do that. So there's my example. Alright, I can do another example right here. And let's just take x times y. If I'm going to just move those around using the commutative property, it's going to be y times x. Now here's another example. We could actually do several ways. If I gave you 5 plus a times b, and I asked you to write a an equivalent expression using the commutative property, we know first that we can just switch it around. A times B plus 5, right? That's just simply switching it around. I could use the commutative property of multiplication from writing it this way. I could say leave the 5 where it is, 5 plus, and then switch the A and the B around. B times A. That's an equivalent expression. And then if I use the way I wrote it up the first time, when I changed it, I could just switch around and put B times A plus 5. Those are all ways to show equivalent expressions using the commutative property. Now, let's move on, and we're going to talk about identity properties. So let's write this down. Alright, identity properties are what you do to a number, okay, to make it equal to itself. Now when we add, we know that if we add 0 to a number, it's not going to change it. So it's going to be equal to itself. So the identity property for addition, it's called the additive identity. It's equal to 0, right? 0 is the additive identity. And then if you want to see it written the fancy way, so if I give you a number A, if I say A plus 0, it is equal to A. It didn't change. I can also say and 0 plus A equals A. Alright? So for multiplication, which is the fancy multiplicative, can't get it out, identity, it is when you multiply by 1. When you multiply, you know that when you multiply any number by 1, you get that number again. So algebraically, this is what it looks like, because we're going to use our variable. If we say 1 times A, it's going to equal A. And we know that I can also use the commutative property and switch it around and say that A times 1 equals A. Alright, so that is the identity property. Now you know that when we have a bar that's written in the form of a fraction, it means we are dividing. And when we divide a number by itself, we know that we get 1. So, for instance, if we have 5 divided by 5, we know that equals 1. We also know that 26 divided by 26 equals 1. So for any number, let's just say A, as long as A does not equal 0, okay, A cannot equal 0, we can't divide by 0, and we'll talk about that another day, but just know that we can't. A over A equals 1. So algebraic expressions like this, n divided by n, that equals 1. M plus 3 over m plus 3, that equals 1. And maybe something fancier, 5y plus 4 over 5y plus 4 equals 1. And because of this, we can use this identity property in multiplication to write equivalent fractions. So let's just say, for instance, 2/3. Alright, and that's the same as 2/3 times 1, right? That's the multiplicative identity. So I can do 2/3, or I can also write it this way, times 5 over 5, because we know that that's 1 based on what we just did, which equals 10 over 15. That's an equivalent fraction. It's the same as 2/3 because we just multiplied it by 1. It looks a little different, but that's how those are equivalent expressions. Okay, so if you were asked, so let's do an example. If you were asked to write an equivalent expression, we'll do an example right here. For 7/5, all right, by multiplying it by 1, and we're going to say that 4 over 4 is 1, so we're going to multiply this by 4 over 4. So an equivalent expression would be 28 over 20. 28 over 20 is equivalent to 7 over 5 because we multiplied it by 1, written in the form of 4 divided by 4. Alright, in terms of algebra, an algebraic expression, here's another example. Okay, this time I'm going to use variables. Alright, I want to write an equivalent expression for x divided by 2 by multiplying it by 1, and the way I'm going to show that is use variables y over y. And we know y divided by y is 1, so we're going to write an equivalent expression. So that turns into x times y divided by 2y, 2 times y. This is an equivalent expression because I use the identity property of multiplication and only multiplied it by itself, y by 1, sorry, didn't mean to say itself, by 1 y over y, which gave us an equivalent expression. Alright, the last thing we're going to talk about today is how to simplify algebraic expressions. Alright, so let's just start with something simple. If I have 3 times 5, we know that that equals 15. Okay? When 2 or more numbers are multiplied to form a product, these numbers are called factors of 15. 3 and 5 are factors of 15. And when the only common factor that numbers have, the numerator and the denominator have, is 1, that fraction is going to be in its simplest form, and we're going to call that simplifying. So let me show you an example. If we have 10, you know what, I'm going to take that back. I'm going to try to do all of my examples in this other color so you'll know that they're examples. Hopefully that will work. Alright, if we have an example here, and we've got 10 over 15. Well, I know that 10 is 2 times 5. And I can't multiply 2 by anything else except 1 to get it, and 5 can't multiply it by anything else to get it. So it's in its simplest form. And I know that 15 is 3 times 5. Both of these are in their simplest forms. I can simplify. I know that 5 over 5 is 1. So I can simplify this fraction down to 2/3. That's how that is just the same as 1. Alright, so here's another example. If I take 36 over 24, okay, alright, let's factor it. I know just by thinking off the top of my head, 36 is 6 times 6. I do know that. And I know that 24 is 4 times 6. And you know what? I can factor it even further. I know that 6 is 3 times 2. These two 6's, I'm going to keep those the same. You'll see why here in just a second. And I know that 4 is 2 times 2. And there's my other 6. Notice why I did that. 6 over 6 is 1. And 2 over 2 is 1. So this fraction simplifies down to 3 over 2 by using that identity property. Now, if for some reason the number of factors in the numerator and denominator don't match, you can put a 1 in its place. Let's look at this one. 18 over 72. Alright, let's factor this out. I know 18 is 2 times 9. And I know that 72 is 8 times 9. But I know I can factor that out even more. 2 times 9 over 8 is 4 times 2 times 9. So to help me line that up here in the numerator, I can say 1 times 2 times 9, just to help us see it better, over 4 times 2 times 9. And if you notice now, look what cancels and becomes 1. So 18 over 72 is equal to 1 over 4. 1/4. Alright, let's look at one more before we're finished. And we're going to simplify an algebraic expression this time, one that has variables in it. Alright, our last example. Let's take xy divided by 3y. Notice, if we need to, we can separate it out. X, and we can use our symbol for multiplying. 3, to help you see, look at that. I have a y over y, and that equals 1. So if I simplify that, it's x over 3. And I know I told you that was going to be the last one, but I'm going to do one more just to be safe, and then we'll be finished. So our last example, let's take 4CD over 2C. Alright, let's separate that out so we can see it a little bit easier. I'm going to say 4 times C times D over 2 times C. And since there's not another one, I'm just going to put a 1 there. We know it's there anyway, so just to help us see what is going to factor out. So I know here that my c's are going to factor out, right? And I also know that 2 can divide into 4. 4 divided by 2 is 2. So 2d, and if it's over 1, we know that anything divided by 1 is itself. That factors all the way down to just 2d. Alright, we'll be doing some work like this in class tomorrow.